Just like the common log that gets used a lot has the understood base of 10. There's another one you'll see that's just ln. So if I'm writing it out, I typically use that kind of cursive L. It's called the natural log. Okay, and its base is e, which is a number. If you think about pi, right? You know pi is a number. It's about 3.14, but it continues on. E is the same way. It's the result of a proportion that naturally occurs. You see it a lot in art and nature, and it's a natural phenomena, occurs in real world, and is sometimes referred to as the natural number. Has another name. If you'll find it and bring it to me, I'll give you extra credit if you can quote your source. When we see ln, it's just shorthand for log base e of something. Instead of writing out log base e, we just call it natural log. It's got its own button on the calculator, right? Because it occurs so often. So when we're writing logs in base e, I can rearrange this the same way we have before and write the log base e, right? What power of e will give me 7, and then solve. But instead of writing all that out, because it has its own log features, I can just translate that to write ln of 7, the natural log of 7, is 2x. Okay, we're not going to solve this one because we were only asked to write the equation. Okay. Again, when we go the other way, the natural log of x, so that's the same thing as saying log base e of x is approximately 0.3345. So when I rearrange that, e to the 0.3345 is approximately our x value. All we're doing right now is rearranging. Okay? So again, e to the x equals 42. Something we could solve, but we're just practicing rearranging. Okay? So here we'll look at how to use this when we are actually trying to solve. Okay? Just like all the solving we've been doing, I need to try to isolate this exponential part. So we're going to subtract 2, 3e to the 2x equals 8, divide by 3, e to the 2x equals 8/3. And then because I have that natural log, I can just come in, and when I take the natural log base e of e, that's going to cancel out the natural log over here. So that leaves me with just 2x equals the natural log of 8/3. Divide by 2. And then we just put all that in our calculator, right? So we know that x equals the natural log of 8/3, all divided by 2. And while that's our exact representation, okay, if I didn't want to approximate, we would stop there. E is irrational. 8/3 is irrational. Okay. And then when I divide all that by 2, it's not going to get any better. But I want to go ahead and get some kind of approximation. X approximately equals natural log of 8/3 divided by 2.4904. Okay. Again, if I go back to my original equation, 3 times e to the 2 times 0.4904 plus 2. I want to know if that equals 10. 3 times, there's this e to the button over natural log. 2 times 0.4904 plus 2, 9.99997. If I started rounding, it would push pretty darn close to 10, so we're good. Okay. I've already got the log term isolated here, so we're ready to go ahead and try to convert it to get at the 6x. So I know that 6x greater than or equal to e to the 4th. Okay. 6x greater than or equal to, and at this point we can go ahead and approximate that. E to the 4th power, 54.5982. Divide by 6. X greater than or equal to, we'll divide that by 6. 9.0997. Okay. And remember, if I want to check to make sure that my inequality is facing the right way, I'm going to pick something that's slightly greater than this. So we're going to use x equals 10 because it's greater. And when I plug that in, natural log of 6 times 10, is that greater than or equal to 4? Well, the natural log of 60 is 4.09. That is greater than or equal to 4, so that verifies our inequality is correct. I can use the same, plug it back into the original equation and make sure it matches strategy if I'm worried about the number that I got. Okay, so again, we used x equals 10 because it's a little greater than our answer. Because it works, I know that we're headed in the right direction. Okay. Last example, I've got the log term already isolated, so we're ready to rearrange. 4x minus 1 is less than e to the 2nd power. E squared is about 7.3891. For x minus 1. And we just solve. Add 1 for x less than 8.3891. Divide by 4. X less than 8.3891 divided by 4. 2.0973. Okay. And again, I want to make sure that my inequality is correct. So this says I need something that's less than 2.0973. Well, I could just use x equals 2 because it's just less than that, and we plug it in. Natural log of 4 times 2 minus 1, is that less than 2? Natural log 4 times 2 minus 1. Okay. And I get 1.9459. That is less than 2, so I know my inequality is correct. X should be less than 2.0973.